Okay, the recording has started. Take it away.
Thank you, Len. Good morning, good afternoon, everybody. My name is Dinesh Chandrasekhar. I'm part of the product marketing organization at CA. Joining me today on the session is Balaji Radhakrishnan. He's a senior principal consultant of the pre-sales division at CA. Together, we are going to be talking to you about API security, a very key topic, and we're going to be talking about what are the various considerations that you could take up in terms of securing your enterprise APIs, internal, external, private, public, however you may look at it. APIs are APIs that need to be secured if you have a wide range of consumers across multiple devices and channels. So if you are joining us today for the first time in the series of sessions that are going to be happening over the next few weeks, this one is primarily going to focus on API security, the breaches, risk mitigation, what are the different types of steps that you can take to avoid such risks that you can put your APIs through, and then what are the different API management solutions that we have at CA that can help mitigate these kinds of risks. So, and then we'll be following it up with a good section of the session for a demo that Balaji will be using our CA technology solutions for showcasing, what are the steps that you can do to prevent such breaches from happening. We talk about digital transformation. This is a topic that is very near and dear to the heart for a lot of the digital enterprises today that are trying to get to their customers through various channels and media and devices, whether it be like cloud services, whether it be like mobile applications. They are reaching out to their customers to enhance their business opportunities, to create and generate more revenue through these various opportunities that they are trying to leverage. But interestingly, with each and every channel that they chase through in this omni-channel approach, they have to leverage APIs because APIs have become kind of like the de facto standard for digital enterprises to expose securely their enterprise data to a wide range of consumers, internal and external to their enterprise, whether it be partners, whether it be external developers that are trying to create applications that can communicate with their enterprise systems, whether it be mobile applications that they've developed for their own customers and partners or suppliers or vendors, and then the cloud services that they have, whether it be their own enterprise systems that they are hosting outside on a SaaS application or a PaaS platform. Or it could be one of those scenarios where they're having a hosted solution that partners and customers are subscribing to. And then, of course, the IoT talk that is happening everywhere, connected cars, connected devices, connected home, and everything that brings about a wide range of devices that need to have access to your data, access to consumer data, exposing them in a considerably secure way, and then also the fact that each and every IoT device has sensor data that they need to communicate constantly back and forth across these wires. So if you look at it, there's an immense amount of traffic going back and forth, and it's not just like, traffic from a volume standpoint, but also from a sensitivity standpoint. There is a lot of sensitive information like credit card infos, a lot of information like personal information that gets transferred across all these different channels. And that's why, the emphasis on security becomes even more important. So the moment we talk about APIs as kind of like the de facto standard, obviously hackers are going to exploit the same scenario as well, saying, how can I get access to that data, access to that sensitive data through the mechanism of the same APIs. So this is, again, gaining access to your enterprise data. So we need to make sure that we are securing them. And securing them is a very loose term. We need to identify how hackers are actually gaining access into these systems and how to actually curtail such efforts by putting in the right set of measures. And this could be ranging all the way from putting in a simple password to extensive amounts of validation, multi-factor authentication, and all that stuff. So we kind of need to assess and understand, where these APIs are, who the consumers are, what the usage pattern is, and how do we secure them. So let's talk about the broader aspect of API breaches. reason why we are even talking about it today is that enterprises tend to take API security very lightly, unfortunately. Large enterprises, if you look at some of the names out here, we are talking about like the Teslas and Snapchats and, Yahoo. Every one of these enterprises is renowned to have a brand, is renowned to have a large, consumer following, and is renowned to have a lot of innovative solutions that they've come up with. But interestingly, with all that kind of digital transformation that they've achieved, the true nature of allowing access to their enterprise data to their consumers is not being treated so sensitively, unfortunately, that their APIs were very easily hacked into by these hackers, and all that data was unfortunately exposed. So this basically led to a loss of trust with consumers. This basically leads to business models dwindling, questioning the capability of the enterprise to actually hold the data security. There are, again, a wide range of issues that we can talk about, as to how these hacks actually happened. Is it that the enterprise actually took all that effort into like securing it, but still hackers were able to gain access, or was it like, really loose? It's actually both ends of the spectrum. There are companies in the connected cars of today, like, not only just Tesla, but if you talk about the Jeep hack that happened last year or the year before, where they were able to shut down a car remotely right in the middle of nowhere through an API call. The Nissan Leaf hack, which I'll be talking about as well, where they were able to access a remote car just with the access of just a VIN number. Any one of these scenarios is about an unsecured API. And when I say unsecured, this is predominantly like, written by a developer or a group of developers within the organization, and that was intended to be an internal API, but unfortunately it was not secured, and so it shipped out as a part of the larger ecosystem of APIs that, enable the computer on board the car, and which basically hackers can very easily gain access to when it's unsecured. And, obviously they can understand what the headers are, what the control points are, what kind of sensitive information gets transferred, how do we get access to the data based on the parameters. So everything gets to be very easy when you have such unsecured APIs. But then there are also secured ones, like for example in the Moonfig example that you're seeing up there on the screen. They are one of the bigger well-known brands in the UK. They make greeting cards, personalized greeting cards and all that. But they secure their API with basic auth, with username, password, and all that. But they also put it through HTTPS and all that, thinking that it's like going to be secure. But it was very easy for the hackers to actually intercept that, understand what the credentials were passing through, and how to like actually fake it by using a simple machine in the middle kind of a system, and actually hack that API and get the relevant kind of information that they needed, basically client impersonating that particular API and saying that, we are also a relevant one, relevant user, authenticated user, and you can get me all this information, and the API was able to get them all the information. And so personal information like, usernames, passwords, but also, beyond that to like addresses, phone numbers, and all those kind of become very, very easy to access with such open APIs and these hacks. I talked about the Nissan hack, and I'm just trying to give you a sample of how easy it was for a hacker to get access to the Nissan API. This API was, primarily part of their HVAC systems and all that, inside the car. But, the API, if you look at it, it is very easy to see that the parameter in there was just a VIN number. So the hacker was basically able to get access into this, replace the VIN with a different VIN, and you were still able to get access about that new car for which you supplied the new information for the VIN number. And this is not information just about like remotely controlling the cars, AC and all that stuff, but it's like actually reading private information like user ID, what's the status of the battery, where did that particular user go, like driving history, so tracking all that. Everything was like readable with access to simple stuff like this kind of an API. And when you have one API, it's not like just going to be stopping there. The hacker is going to sniff around and find out other APIs related to that, and again be able to like simply hack into it just because it's unsecured or the mechanism does through which it was secured, whether using a auth token or whatever it is. Once they secure the token, then it is easy for them to like kind of find all that other information very easily. And the more important point to emphasize here is that not only just Nissan, every other enterprise that we talked about earlier too, even though the hack was discovered and the hackers were, again, this was done through ethical hacking, right? So obviously they reached out to the company and they said, hey, we found a vulnerability in your API and you need to fix that. There is an exploit that, could potentially be used by malicious people. It took them several months to actually get it fixed, which is a big, deal, particularly when you know that there is an exploit, potential exploit that could happen, and you're allowing it for months before you could actually fix it. That's a major challenge. Companies need to be more agile. If you want to be a digital enterprise, if you want to secure APIs, not only do your security measures matter, but also the fact that you are able to act quickly, react and perform the right kind of security measures that you need to take into place in an effective manner, in a timely manner. So let's talk about the top 5. It's kind of like broad categories, but at least the areas where how APIs can actually be hacked. Again, when I say hacked, there are multiple ways how it can be done, but we are taking up kind of the broad 5 categories. Client impersonation, phishing, brute force, injections, and then unauthorized access, compromised secrets. Right? So these are primarily 5 broad areas. And some of the things that I already talked about, could fall into any one of these categories. We'll go through it and we'll, find out how they fit in and how we can actually address that. Client impersonation is an area where you've, an attacker primarily understands, what the secret is assigned, to a particular app. This could be like a OAuth key, and once they discover the OAuth key, then they could pretend as though they are a legitimate app and make some calls. Like for example, in 2013, this happened with Twitter, where it was published on GitHub about the OAuth keys that were used for Twitter, what the Twitter developers were using. Those OAuth keys are actually published, and this potentially posed a threat to Twitter because anybody could potentially mock themselves, pretend themselves to be a legitimate app like Hootsuite or TweetDeck or any one of those apps because they have the OAuth key and they could make those requests and get access into sensitive information. Snapchat, same thing. There was an exploit similar to that where they were able to the hackers were able to identify the key and they were able to tap into similar information into Snapchat. They basically exposing 4.6 million users type of information. That's very, very, because data is king. Unfortunately, that's how it is. So if your API is compromised, data basically gets exposed and you basically lose business. So how do you mitigate something like this? It's either confidential or it isn't, right? So you don't basically hide a secret on a public app store and render it on a web page. That basically is a no-no. So you have to assume basically that every single client that is going to be using your app is a public client. So there's no room for error there, and just don't grant access because it's an app that has an identity. Just don't grant access to it. Make sure that you have some kind of a user auth set in place as well. That will prevent at least a 2-step approach to saying, okay, it's a validated, authenticated, approved app, but still the user credentials limited from having some kind of a random hacker tapping into your OAuth key and getting into it. The other type of attack would be a phishing attack, and this is probably very commonly known because a lot of identity thefts and everything happen through these kinds of mechanisms where the malicious application pretends to be as though it's legitimate by inserting its own endpoint as its callback address. This is a very common way to do it, where typically an application would request for an OAuth key, and it would get a OAuth token back, and it'll basically get access to the API, and it can call the API and do it. But in a scenario like this where an attacker is trying to do harm, the malicious application would pretend as though it's legitimate, but the callback URL would be their own URL. So when they get the OAuth token, they basically redirect it back to their own website, and they basically can make it look similar to the actual website, whereby the user is thinking that they have been rerouted to the original application or the legitimate application, but in fact they are not. And so they are submitting all this information and very personal information like credit cards and all that stuff. And the hackers basically gain access to your personal data and financial data right after that. So this is very common, as I said, but this is about how the redirect URLs are not being tracked. This is a great scenario for that. So how do you prevent that? Register and validate these redirection URIs. Make sure that you understand, because this is within your control. You know how and where it is going to be redirected. So these URIs can be tracked and they can be registered and they can be validated. So make sure that when you're redirecting from the point where you're supplying the OAuth token, you are doing that you understand where it is being redirected to. Strict validation, again, not just partial, but really validating the request appropriately, and making sure that there is a consent step as well. That is also important because some of these are like kind of automated bots and those kinds of things. So it's very easy to kind of walk over that very easily if you don't have that kind of a step in there. So make sure that you have that kind of a mechanism to prevent phishing attacks as well. Brute force. So this again is a very common type of attack where we are talking about a large, massive amount of repeat attacks where whether it's about understanding a particular password or getting access to a particular key, or maybe trying to create a mass number of accounts, bogus accounts. Any one of those are basically brute force because you're trying umpteen number of times as a hacker to gain access into an enterprise system. Now, as simple as it seems, the moment I say umpteen number of times, you should be going I should be able to block that kind of attack, by saying you can have only X number of attempts in a particular time frame, or X number of retries within a particular day, or whatever be the rule or policy that you set in place. But interestingly, a lot of enterprises don't do this, and they realize it too late in the game that they've been attacked by a brute force hacker, where they've been trying it over and over again, and the account did not get locked, and they were able to create so many bogus accounts, or gain access into a lot of sensitive information as well. And that happened with Snapchat, where this kind of a brute force attack happened, and they were able to gain access and map out phone numbers to actual member names and all that. Gain access to sensitive information like that, as well as create millions of bogus accounts and all that too. So in a sense, this can be very easily prevented by mechanisms where you are able to limit the rate at which the requests come in through, assign quotas to specific consumers or a range of consumers, having some SLAs. Again, those are all definite patterns into making sure that you are limiting these kinds of attack vectors from targeting your APIs or your systems by making sure that they have only limited access to such resources, which they can be, again, prevented by calling in failed authentication or limiting password resets or something like that. If you detect those kinds of patterns, you can raise a red flag right away. Very easy to implement scenarios like that. Correlating identity, location, and concurrency. Again, that's a great thing. It's kind of like a complex event mapping, if you will, where you can identify where a particular event happened, who's making the event happen, and whether it is simultaneously happening at multiple places or multiple times or multiple accounts. So identifying those and correlating that to make sure, okay, now I see a pattern between this. It's kind of akin to a credit card fraud, where you can think about somebody using a credit card in San Francisco, getting out $100 cash, and then at the same time, the same credit card is being used in an ATM in Barcelona, and they're getting $200 cash there. So same person cannot be at the ATM in two different places trying to draw cash out of two different things. Correlating that would matter. If you look at it as separate events, obviously they are different. But those kinds of correlations again matter. Even in the API attacks. rate limiting to protect backend APIs. As I said, when you have mass number of attacks like DDoS and all that, understanding that kind of a pattern and making sure that you're limiting the rate at which the APIs can be called prevents this kind of an attack as well. And then injections, very common, age-old type of attacks. It has reduced probably a whole lot. Having that, it's become so common and people understand how it can be prevented. Because if you look at how it is done, typically a URL call or a URI call, where the parameter basically is something like a member ID is, or transaction ID is equal to, and there's a number there or a string there. You can attach the transaction ID to be as simple as where ID is blank or 1 equal to 1, which means it basically is going to validate against all the records, and it's going to get me all the records instead of one particular record. It was very easy to do because the backend code would basically say select star from table where ID equal to that, right? And instead of that, you're basically substituting this string, and it will be able to get all the records from the backend database. So this used to be very common. Again, a lot of newer development mechanisms have put in place that they are not using such simple and dumb mechanisms, but still, dumb exists amongst us. We have it, and that's why hackers are still able to gain access. So this is still possible. There are systems out there. There are companies out there that use mechanisms like this. Developers do make that mistake of exposing these kinds of URIs, and that's how everybody gets access into it. So how do you prevent that? Very easy to talk about input standardization, parsing the input parameters, not taking the entire parameter as a variable substitution, but maybe taking in a substring of that. If you know that your member ID is going to be only 6 digits, taking in only the first 6 digits. That way you're not taking in all the other extra stuff that a hacker could potentially given your payload or your transport. Understanding pattern validation. So, if it is just a member ID, you know that it is following a certain pattern, and making sure that, it is following that particular pattern, and you're able to tap into that. If it is not, then you're able to identify, okay, this is a wrong pattern, and you have to come up with a flag saying, incorrect in a member ID or something like that, instead of taking it back to the database and running the pattern against the database. And, similar things like that, but important to understand that these patterns can be identified right at the policy level where the request comes in through, rather than taking it to your backend system and then validating it there. And then finally, unauthorized access. This is kind of like the similar thing that I talked about with Nissan hacks, where there was an unsecured API or authenticated client, getting access to resource that should be restricted. Even though you've authenticated them, it doesn't mean that they should be able to access pretty much everything. They have access only to certain resources, but not allowing that level of security again could be a challenge. And then session secret, compromising that, again that could be a challenge too. But this is where you make the balance between UX and security. People always go the hideout by saying, hey, if I ask for too many, user credentials and security questions or stuff like that, it spoils the user experience for my consumers, and I don't want to lose them. So basically, letting it open or making it anonymous or making it unsecure kind of encourages hackers to very easily tap into your applications and potentially your data. So balancing that out, making sure that your UX is still not taking a hit, but also appreciating the fact that you're doing it for your consumers, even though they might feel a little uncomfortable about the whole thing. It is for them that you're actually doing this. Make sure that security becomes your primary focus. Again, this can be done with authentication, a lot of different types of authentication, whether you're using social logins, federation panels, all different types. Token issuing, we talked about OAuth and all that, so there are different types of, mechanisms like that that you can use. Tokens. Scope, making sure that you're granting users only specific permissions on specific types of users, even though they are authenticated. And then, making sure that your identities are mapped to specific resources. Again, making only specific identities having access to specific resources. All that will help as well. So having said all this, how does API management actually help here? This is a very important question to answer because we talk about at CA API management across a comprehensive end-to-end kind of a message, and it's very important that you understand that API management is not just about the APIs that are exposed and just putting some security around it. Perimeter security is gone. I mean, it's gone in the sense that that used to be kind of like the mantra of the yesteryears, but as you can see, that alone is not sufficient anymore. We need API to app, that level of security where security is inherent in each and every step of your digital transformation. So you talk about integrating and creating applications. This is like embracing your existing applications that are already there, whether it be like, SOA-based applications, ESB applications, legacy applications, trying to embrace them, but at the same time be conscious that these legacy applications could carry their own inherent security risks and trying to attach security on top of that, again, that would come in handy. The open enterprise, we are talking about, making it a digital transformation, which means you are opening up a lot of your enterprise systems and enterprise data to a lot of vulnerabilities out there. So making sure that you're protected against those kinds of threats and having controlled access to your systems, either through single sign-on for like, better user experience, identity management to make sure that the right people get access to the right systems and all that. And again, as I said, end-to-end security for apps, mobile, and IoT devices. We also talk about mobile development, where you're talking about application building, but not just from the UX standpoint, but from actual back-end application building, where user management, group management, security, everything becomes a very inherent part of each and every enterprise app that you build out. So talk about security even from that standpoint. And then unlocking the value of data, because you are talking about data being exposed to partners and customers. So you might want to monetize on that kind of capability. And again, this becomes very important too, because you're talking about data being exposed out there. How do you not only just unlock and monetize, but also still keep everything secure. So with that, I want to give Balaji enough time as well to talk about how the architecture of CA fits into the overall scheme of things that we talked about, and give us a nice, cool demo that he can show us with touching upon some of the concepts of mitigation that we talked about. So Balaji, take it away. Balaji, are you on mute?
Yeah. Nope. We can hear you now.
Yeah.
Oh, okay. Oh, cool. So Dinesh, can you bring up that slide deck, please?
Yeah, I'm sorry. I think Glenn transferred the control.
Yeah, hold on one second. Sorry, guys.
No problem. He has a few slides before he can go to the actual demo, so hold on a second.
There you go, Dinesh.
Yeah.
Okay, cool. Can you go to that slide?
Absolutely.
Yeah. Okay. Thanks, Dinesh, and hello, everybody. I just want to jump in and take the context from where he left. Dinesh has given a lot of information, and from CA API product suite point of view, I just want to highlight certain products and set the right context before we jump into the demo. That way you know that what products and what components that they're using, not only for development of the policy, but also for securing and protecting and also throttling the API. So to start with, as very clearly pointed out, everybody jumping into the digital transformation journey and everybody wants to expose the data, but in a more secure manner. That's where the live API creator comes into picture, whether it is structured, unstructured data, or SQL, no SQL. We can point the live API creator and very little configuration. We can point, click, and pull all the tables, views, and procedures and create CRUD-based, REST-based CRUD APIs. Once we create the APIs, it can be published into the gateway, and that's the API gateway, the mobile API gateway that you see in the center of the diagram there, where you could secure the API for authentication and authorization. We can also protect the API, all the vulnerabilities that has been articulated by Dinesh, and then you could also throttle the API, rate, limit, quota, threshold, and so on and so forth. Once you have all those things secured, then you could publish that API for your developer or partner ecosystem. That's where the portal comes into picture, where the consumer can come, discover, interact with the API with the help of Waddle, RAML, Swagger kind of a documentation, test the API. If he likes it, he can register and then subscribe for the API. Once he subscribes, then on the runtime, the gateway takes him to the control and provides the required protection. Can we move to the next slide, Dinesh? Okay. So with that said, the CA Security and API Management platform is a very flexible solution that consists of multiple components based on your business needs. Start with the gateway. This is a workhorse of the suite, and either it is translating the API between the frameworks, or routing, or protocol switching, or bridging, or throttling, control, prioritization, caching. Many of these things are out of the box, and enterprise security comes out of it. Similarly, the security component, which we are more focused in this particular thing, we will be seeing more of that authentication enablement through API keys, social hooks, or OpenID, OAuth, two-leg, three-leg, and also SAML, and so on and so forth. And finally, the ability to manage the lifecycle, including the tracking, performance monitoring, staging, configuration, and also from the developer point of view, the environment plans, the API plan, the account plan, and the Explorer for the consumer point of view, the documentation, the quota, all those things. It's from the management point of view, it helps. Dinesh, can you move to the next one, please? Okay. With that said, this is another context setting diagram. This is an industry standard where we usually see many of our enterprise customers do deploy a cluster-wide a gateway cluster in the DMZ and expose that to the outside traffic where the partners, vendors, third-party developers, everyone come in. And this is very specifically handles certain information like authentication of the user, authorization of the user. If it's not authenticated or authorized, you could send it back before routing it to the trusted zone. Similarly, you could protect the API, whether it is a cross-site scripting, denial of services, rate limiting, throttling, so on and so forth. Many of these things can be handled in the DMZ. So once it is all done, the secured manner, once we validate the user and protect the API and we all feel that it is comfortable, then this one routes it to the trusted zone where actual orchestration, routing, any kind of a traffic management, as well as integration with mediation or so on and so forth, all internal business logics can be taken care of. So this is a deployment view of the use case which I'm bringing it up. The last slide, please, Dinesh. Now, for the demo purpose, I'm going to use Policy Manager, where the actual development of the policy will be executed, and also the gateway is in the middle, as you see there. The gateway we can integrate with any kind of LDAP, Active Directory, Kerberos, and so on and so forth for internal user authentication and authorization. And also the live API creator can be integrated directly for publishing the APIs. The data APIs can be created by pointing it to the data sources, and the developer portal can be integrated for pulling and publishing the catalog, and also for the developer community to access. And the apps that is on your left-hand side is, for this demo purpose, I'm going to use SOAP UI, so that this way I can run as a client and test my policies and show the demonstration. Hope setting the right context and right use case here. With that said, can I have the desktop?
Len, can you transfer the rights to Balaji?
There you go, Balaji.
And another thing for the attendees while Balaji is setting up his desktop is, if you can kindly submit your questions on the Q&A panel. We'll have some time at the end to address the questions as well. So feel free to do that while Balaji is going through his demo.
Okay. Dinesh, you guys are able to see my Policy Manager, right?
Yes.
Okay, cool. So this is the Policy Manager. This is where all the actions happens, and this is where the API development developers come in and develop their policies to protect their internal APIs or web services call. So as you see here, this is the policy assertions out of the box. There are 300 plus assertions, whether it is an access control, whether it is a threat protection, whether it is a security audit, logging, so on and so forth. They've been categorized and then they have been showcased here. So out of the box, all the OWSAP 10 vulnerabilities can be handled. No need to have additional coding or things. And similarly, you could have access control, whether it's an internal identity provider or it is an LDAP, Active Directory, or Kerbos, or OAuth. Many of those things are out of the box, and you could use them directly from the assertions here. Similarly, logging, auditing, it's another area, whether it is a financial sector where PCI is compliant and so on and so forth. Many of those things can be handled here. And you could create templates, and you could also come up with your own custom assertions. If it is not satisfying, you can have those assertions here. So with this intro, then this is the area where you're seeing now highlighted. This is a gateway. It could be a cluster. It could be a web. This is where you could create, organize all your APIs. You could create your SOAP-based API using WSDL, as well as publish directly using the URL. You could also publish an API or create an RESTful API using a WADL, Swagger, and so on and so forth from the gateway point of view. You could also create policies. Fragment, this is another important segment where I want to a little bit emphasize, because from the security point of view, it's not everybody can focus on every area, whether it is audit, logging, security, protection, and so on and so forth. Many of the enterprise have distinguished classified categories and roles who can do that. So those people who are specialized in security, they can go in and say that I want to create a basic authentication, something like that. And the moment they click, they can go and create that policy here. And all that they need to do is go and drag and drop, say, hey, I want basic authentication. I want to authenticate against, let's say, in this area, in the internal identity protection. And that's all. The policy is ready now. The fragment is ready. And they can use this fragment, give it to somebody who needs to include for the internal API, especially when it comes to the internal API. For internal users, most of the users are going to be in LDAP or in Active Directory or Kerbos, where they can validate who is the user, which department is asking based on role-based, attribute-based, and then you could evaluate and provide the required authentication. This is an example I want to show. Next one I want to highlight is the identity providers. You could create an LDAP or simple LDAP or integrate with your enterprise-wide LDAP solution. You could create a X509 certificate. You could create a FIPS and add the user. Another key area I want to use show the certification. You could go and import or add a certificate from any of the system. Most of the places where you see the gateway will be in the trusted zone, and all your backend systems like TIBCO, WestSphere, Oracle, or Fusions, most of the SOA components will be inside the trusted zone, but those are app servers. Now, in order to make sure that no one else can access, only the gateway can access, we can create mutual authentication, create the certificate, and then use the certificate for that mutual authentication between the gateway and the SOA component, right? So that way it is much more, again, this is talking about the internal authentication. So we can use the basic auth for internal API. We can also use a mutual authentication for the accessing the web services between the gateway and the backend solution. Similarly, we could also have private keys. This is to make sure that for partners, you could create private keys and hand over the property, hand over the keys to your partners. And whenever they are trying to access the gateway, they need to come through those keys, which gets validated against the certificate that you have created. In my case, for my policies, I have used this micro mutual auth as the certificate, and everyone who comes in with that certificate is the one who will be able to access this APIs. So again, we can use the mutual authentication for users, internal servers to access between them, the gateway and the SOA components. We can also use the SSL-based certificates for external partners and vendors who you know very well, and they have the specific components and they can hand over the keys and they can access through that. Again, from the external point of view, OAuth along with the SSL certificate is another combination usually flies, and that way we can have a two-factor authentication. Now, in addition, we can also have SiteMinder, kind of an SSO single sign-on combination. This way you could not only have two-factor authentication, but also you could generate an SM session token, have the token added to the header for the backend web services, so they can in turn authenticate and authorize if this is the same person who is saying that he is, and make sure that, so independently if there is people who are coming outside the channel of the gateway also can handle the same service, or the people who are coming from the gateway can also have. So this is another area. So in order to show this security capabilities, what I did was I put together policy. I built the policy because I have only 20-25 minutes time. So this is where I dragged and dropped the SSL transport with a client certificate. I'm mandating them. I want a certificate. And I'm also authenticating that against the X509 certificate I created. And I said that authenticate against them. If it is not, if it is authenticated, then I'm pulling them some extract from that certificate for the validation, expiry date, or CNDN kind of information. And I can do additional validations also. But these are all out of the box. I can pull so many information for the certificate, and the capabilities are out of the box from the gateway point of view. And I also request them to provide me a OAuth token. I'm saying if you're coming, this is the second factor. I'm saying if you're coming, you need to come with a SSL certificate. You also need to come with me an access token. Only then I allow you to do that. But for the sake of combination of many things I want to show, I also added another segment here where I generate the token. I also display the token, and also the SSO session token, SM session token, and I'm displaying it as part of the proof. So for this demo, I added, usually I won't add this inside the API. And these are all exception handling. If it is something goes wrong, what and how and kind of a thing. And then I also have another segment where the capability is you could do a query-based, header-based, URL-based, and content-based routing, and those capabilities also can be seen. So the first one is this policy I want to show you. Now I'm going to take you to the policy manager, SOAP UI. So I'm providing certain information. As I said, usually I just need to provide the access ID or access token from the thing, but for the sake of demo, to display various capabilities along with SM session token and all those things, I'm also passing additional information for the sake of POC so that I can generate the token within the policy itself. And finally, if everything is fine based on the routing, I'm also routing to actual path or to a virtual path. So this is again from the DevOps point of view or testing point of view. If we are not ready, we can create stubs and enable the developer community to access the virtual path until the actual one is coming in. And this way, we know that, that once the actual one is ready, just switching behind the scene without impacting the developers and the integration testing and so on and so forth. So this is an actual and the virtual APIs policy. This is more like a backend SOA component you could assume for now. And so once it is successful, I'm routing it. Since the environment, everything is in my laptop, I created that within my policy manager. Okay. With that said, I'm going to send that information. And you see here the hope it is not taking a longer time. You can see the information that has come back from the policy. So here I'm doing an call to the actual service because I'm not adding any routing parameter here. So it goes and you see the actual client information. I gave the base 64 encrypted client ID information, which goes there, and based on that, it generated the access token. And also, it integrated with a single sign-on where the actual URL that was requested is being verified and validated whether it is protected. If it is protected, whether it is authenticated. Whether then if the user information that I shared is authenticated, then whether that user is authorized to access the backend component. If it is all good, then it is routing. And also I mentioned that mutual authentication using the SSL certificate. If you see here, I'm also passing the certificate key which I generated from the gateway, and I'm sending this information. With that, it also pulls the certificate information and says what it is. So in reality, the access token will be the first factor and the mutual auth will be the second one based on the partners. Or you could end up only with the access token. Whoever comes with the access token, they can do that part. This is from the threat protection, so from the security point of view, we do that. And also if you see here, I'm saying this is URL-based routing. I'm routing it to a different policy now where the URL-based routing will be taken care, or I can also do a query-based routing. So this time it is a query-based, and we can similarly do the routing to the header-based also. So you have a very flexible way of handling security, making sure how the internal APIs can be handled, external APIs call can be handled, and so on and so forth from the security point of view. Right now in this example, I showed 3 of them. We can also have SAML, JSON web token, or any kind of a hashing generated token, so on and so forth can be done that out of the box from the gateway. Okay. So now going back to threat protection, this is another policy I have built from threat protection point of view. Again, I'm expecting a XPI09 certificate here. Without that, I won't allow them to move forward. I'm also expecting a basic authentication with an internal identity provider. I can change this to an LDAP also, or any Active Directory, or even a Kerberos key fab, or whatever it is, we can validate the same thing. We can also, if it is a SOAP-based services, I can also expect a SAML token. So the prior one will be generating a token, and another one will be sending the token, and we can validate the token that has been taken along with the segment. And once the authentication is done, I'm also doing a threat protection. So here, some of the threat protections, what the SQL attack, what Dinesh was mentioning, the code injection, and also cross-site scripting, rate limiting, and the size of the message. So there could be some culprit who will be sending messages, large payload, just to bring down the server. We can limit the size of the payload and make sure that it cannot go beyond a certain point. For the sake of this example, I have built a very huge size of payload, and I also mentioned that the payload limit is at this point is 10 kilobytes. I can play around with this and as part of the demo, and I can show you how we can limit and do that. This is from the threat protection point of view. And then I'm also doing service availability, the throttling, and as mentioned, rate limit. So I'm saying 100 transactions per second within a 1 second window, and it's spread across 10 across the cluster. I can do this, and I can throttle, shape, log only if anything goes beyond. Or I can also apply a quota saying how much ever it goes, but the limit is only 200 per month, or 2,000 per month, or 20,000 per month, or something kind of that, and increment based on the authenticated user, and anything beyond that, go just log the information. So all this information is out of the box, and I can also restrict time of the day or day, which days I need the service API to be available. And this comes handy for the example, if it is a microservices kind of a thing that you guys are trying to do, then we can also play around with that. And finally, since I cannot put all kind of restriction, I'm trying to show you as an example here. I can have an IP base. This is the IP address of my own laptop. So I'm saying anything from this to this authorized for now. I can change forbid, and I can control the access of the IP address based things. And again, you could have a query based, and you could also have the same routing mechanism here. So with that said, I also want to take you to the SOAP now UI, where if you see it is a successful thing that has come back. So if I try to introduce a code injection here, and immediately it should fail, saying failed due to the code injection. Similarly, if I'm trying to add some kind of SQL saying, let's say, something kind of this, and it should come back and restrict me saying that, hey, failed due to the SQL attack. So let's say if we are, then I can play around. I can also make sure that size, I can say that I only want 1 kilobit size, and if someone is sending me more than that, we can restrict that based on the fail due to the message size because I restricted them. And finally, I could also have authorized, but I can also have a forbid of the same thing. So let me save this and go back and see the success scenario of this. And now I say instead of authorize, you forbid me. And at this point, it should not allow me to move forward because anything with that IP range I have restricted. Similarly, we can also control certain things using port numbers. So let's say 7443, which I configured, I said that anything comes in this particular port number, you route it to the virtual component. Don't even think about anything else or who sends what information. Even though I'm sending the actual here, it will not listen, and I can force it to a particular factor. So these are all various ways you could control the flow, secure the API, protect the API, throttle the API, and so on and so forth. I think I have 7 more minutes. If there is any questions I can take up, or Dinesh, if you want to share something beyond that, let me know that.
No, great demo, Balaji. And I think one of the key things that I want to emphasize here is that security is definitely a key thing to consider. And given all these different types of threats and vulnerabilities out there, the capability to configure your gateway and set up these kinds of complex policies with such very minimal configuration changes, the just opening up a property and changing something real quickly and be able to in a very agile way, configure the security policies is what would help a digital enterprise today. I think that's a key takeaway, what you demonstrated today, that you were able to change on the go, so many different things, in such a easy way. We do have a few questions, Balaji, that are coming up. Maybe I'll just punt a few of these things to you. The first one is, do I have to create a FIP in Gateway for certificate-based authentication, or can I use an existing one in my environment?
Yeah, sorry, I was on the mute. Yeah, you could reuse your existing, and if out of the box you have the capability to do the same, and you could authenticate against that also. Yes. Okay,
good. And then the other one is it possible to share with attendees the API Balaji is demonstrating now? Is there a way that you can share that, put it on GitHub or something?
I didn't get the question.
The API that you were demonstrating just now, they wanted to see if you could share that with the attendees.
Yeah, there is no problem as long as you have the environment. You can comment out a few lines. If you don't have an SiteMinder integration, you could comment out certain things. And there are certain segments, for example, I was mentioning I'm doing a OAuth. This section we can comment it out because this is all expecting SSO integration. So we can comment out and then reuse as long as you have a OAuth. And also certificate, you need to change this to whatever the certificate authentication you're trying to create and go ahead with that. So there are some changes you need to do, but yes, you could reuse the policies.
Cool. And the last question that I have here is, what's the impact on policy execution latency if we try to add all the possible and relevant security validations as per the requirement? Is there any recommendation best practices on what would be the generic security validations to be done?
Yeah, that's a long, big question. But to start with, the gateway, because the policy execution itself is based on various factors like encryption, hashing mechanism, requesting or generating a token, or any kind of a transformation and authentication and authorization, and all those things adds up to the policy. If it is a simple pass-through, that's a different story. But also, there is a latency that you need to consider from the front-end load balancer or firewall or something kind of that reaches the gateway, right? And also the network latency you need to consider, and the payload you need to consider. There are many factors that you need to put together, but you could play around for the optimization of this. There are timeouts from the gateway to the backend system based on your SOA component latency. You could fine-tune this. There is a default that has been given by the gateway, but you could fine-tune this, and you could play around with the latency so to have a more optimized utilization. So you need to think through this both from the front-end load balancer that comes inside. There is again a default cluster-wide property that gateway provides where you could set some parameters, how many I need to take from gateway point of view based on my resources, based on my backend, how many I'm going to take. So that you can control, as well as from the gateway to the backend, the latency you need to. So to answer in an indirect manner, yes, you could control throttle based on the information that you have.
I think the question is also on, do I pretty much like create all different types of relevant security validations and everything, and load up my policy in such a way that it covers all bases? Would that mean then the policy execution takes longer to execute, right? So I think they were leaning onto that as well. But I think it's a longer conversation, as you put it, in terms of best practices and stuff.
Yeah, and it also depends on what you're expecting, right? Who is your partner? Who is the vendor? Are you opening up to the third parties, and or it is an internal thing?
Exactly.
Certain things you could, based on what you need, only those things. For example, I added only 4 or 5 threat protections, which is quite standard, what I believe. And if it is internal, I may not add. I may remove some of those IP-based restrictions or payload-based restrictions. If it is external, I will go on. So you need to think through what you need, and accordingly, you could pick and choose what you want for your API protection.
Yeah. Sorry, one last question. Maybe we wrap up, and then how is an OAuth access token obtained? I think you answered it, right? Didn't you show that in the demo?
Yeah, I showed.
Yeah, I thought so. So I just want to make sure. Yeah, that's what exactly. So I just want to make sure that.
There is an endpoint. OAuth, because OAuth toolkit is part of our journey and part of the gateway, it exposes endpoints, so security endpoints, and the endpoints based on the DMZ as well as the trusted zone, how you distribute them. But these endpoints are available. Some of them are public endpoints where this is, for example, I can go and give a call, and it comes back with the tokens, access token, bearer with the bearer concepts, and the refresh token, as well as the SM session token, SSO token. Everything comes back, and you could then all that application needs to do is take this access token, and send that. So they can add a SM session token in the header for additional multi-factor authentication. So these API endpoints are available for them to access.
Perfect. We are out of time. If you have any other questions, definitely feel free to follow it up with us. There will be an email following this session with the recording and the slides and everything that will go out to the attendees. Feel free to reach out to us or to your account teams and let us know of what you think. And if there are any open questions, we'll still love to help answer them. Balaji, thank you so much for taking the time to do this fantastic demo today with me, and I think it was very insightful even for me, watching you kind of go through the configuration parameters so easily. It just goes on to showcase how easy the product is and how it can help our customers as well. So thank you all the attendees for helping us through this session, being patiently waiting through and asking all the relevant questions. I appreciate the time that you spent with us, and looking forward to having you over for other sessions that we'll be having every week as well. So look forward to more invites from us. Thank you so much.